Hey everybody, in this video we are going to not only have point to click and move, but if we hit the G key, a debug key for us, then we can switch into WSAD or a gamepad controller, and now they won't conflict with each other. We either do one or we hit G and we do the other, which means we have proper movement and a much more sensible looking speed. And simplified code, we'll be deleting a script actually while we do this. So I'll see you in there. Let us start then by simplifying and debugging our existing movement code. So right now it's all a bit strange. We have a bit too much going on. We have a third-person user control script that does, well, something, frankly, and we're not quite dived in to find out what. And we also have a player movement script. Now, can we just get rid of the third-person user control? Let's see what happens. So we can click to move, which is what still our primary goal. We're not worried about WSAD or the controller, any form of direct movement. We're just thinking about this click-to-move paradigm. Seems to work, but if we turn off third-person user control, does it still work as expected? No, he runs around like a loony. Okay, so why does he run around like a loony when we do that? Well, it turns out that the combination of move speed and animation speed multipliers, they actually multiply together. So, for example, if this is 1 and 1 for move speed and animation speed multiplier under the third-person character script component of the player, then he moves this fast, so 1,000, 2,000. So about 2 seconds to do the length of my L there. If I was to double the movement speed, let's see what happens, 1,000. He's about twice as fast, okay. But you notice when you double the movement speed that he's taking like these really long strides and he's going really fast with them, right? So the other option is that we double, for example, the animation speed. Let's see what that does. So if I was to go here, 1,000. It's still about twice as fast, but his legs are going 20 to the dozen now. He looks really funny. I quite like it. But of course, if we go multiplier 2 on both, now he's going 4 times as fast. So what was happening is we had very, very high speed set, but the third-person user control was compensating for that. We actually don't need this third-person user control script. What I'm going to do is suggest that we grab some of its code in a few minutes, particularly some of the stuff here about camera relative directions, but that we don't actually bother with it. You know what? Because it's full of things like jump, which for my game I'm not going to bother with. If you want jump in your game, then you can continue to adapt the third-person user control. Again, you're building your game, not our RPG. We're making decisions about our game. We don't want jump. We don't want crouch. And I want to take a bit more control of this movement code. So I'm going to disable the third-person user control script, not quite get rid of it yet. I will apply that back to the prefab, though. I'm going to use a move speed multiplier of 1 and an animation speed multiplier of 2, again, applying that back to the prefab. And what that's going to do is, as we explored a moment ago, give Ethan a very funny but still reasonable movement speed. I like it. Laughing is good because the core experience in our game is funny and absurd. So this is ideal for that, all right? And he's moving around nice and fast. So really, just removing the third-person user control script has fairly solved our problem with the complexity. So let me just go look at the player movement, make sure that all still makes sense to us. We have this walk-stop radius, remember, of 20 centimeters. The idea being if I click, say, on the very corner of this ramp here, that he moves and the animation has time to stop and not run around in circles. The animation may overshoot a little, but it basically, the click to move is fairly sharp and works pretty well. So that's what that's all about. And then we have reasonable dependencies on the character, the camera raycaster, and some cached click target so that this class knows what it's doing. And all fairly simple. So we had an issue with click to move and WSAD conflicting and increasing the speed. Do we still have that issue? Well, actually no, because we're not processing WSAD anymore at all, because we're no longer processing the horizontal or vertical input axes. They were in the third-person user control here. Okay, so we don't have that issue anymore, so we can, at least for the moment, take away the to-do, because that issue has gone. And then in fixed update, what are we doing? Well, we're looking to see in this block here what layer we're hitting. So we say if we hit a button, if you hit the left mouse button, then go ahead and basically all of this just processes indirect movement. It processes a point-to-click type of movement. So why don't we factor this out into a method called process indirect movement? Because I think that fixed update loops should read very clearly. Now, there's a disadvantage to putting lots of method calls inside a type loop like an update loop, which is that you are making more method calls, and that can lead to something called instruction cache, C-A-C-H-E, misses. But that's a more detailed performance issue than we need to get into right now. And apart from anything, we don't have any evidence that it is slowing our code down. So let's not worry about the function calls until we have a reason to. I think it's really important at this stage that our code is clean and easy to read. We could always what we call inline this code, bring it back into the method later. So I'm going to factor this out. I'm going to use the quick actions and refactoring tool. And I'm just going to extract the method. That's great. Like that. And then I'm going to call this new method process indirect movement. And it's indirect movement because mouse and keyboard. We could say that, mouse movement. And then you could ask yourself, is process indirect movement a good name when I have to comment it with mouse movement? And the answer would be no. So Control R, and then just change again, process mouse movement. So all fixed update is doing is processing mouse movement, and then all of this is just the code for that, right? So we've done absolutely nothing, and obviously it still works. But what we are doing is setting ourselves up for the next stage of the video, which is, and it's optional to you if you want the gamepad and you want WSAD to work. But in this next part of the video, what I want to do is implement direct movement. And, if you don't want this for your game, if you don't want to use WSAD, you don't want to use the control pad, well, then, sit back and just enjoy. But I'm going to do that because we're going to be using it in our game. So what we're really saying, firstly at a top level, is that we need to have the concept for the player movement script of whether in direct mode or not. So at the very top of this guy, I'm going to be saying something like is in direct mode, and I'm going to initialize it to false. So are we in direct movement mode? Okay, bool is in direct mode equals false. Now, I might do something slightly nasty, which is make this a static later. To do, consider making static later. And what that would mean is that there's just one place in the entire code base, i.e. here, that determines whether we're in direct mode or not. And I think that that is a reasonable case for a static. But as no other script currently needs to know about direct mode, it may do later, but right now nothing else, none of the UI, nothing needs to know about direct mode. So this may as well be a private variable. In fact, why am I putting it at the top? At the moment, it should just be down there, but the rest of the privates is just a Boolean, right? And it starts false. So we're not in direct mode by default. We are in point-to-click mode. But what we can do in fixed update, we can start off by saying, well, okay, let's just every key press, just process input.getKeyDown. And we're just going to ask the question, are we pressing keycode.g, for example? That could be G for gamepad and G for gamepad. Okay, now this is a bit of the equivalent of a magic number in that we're putting input binding here into the right inside the code. So to do, allow player to remap later. And that's when we get UI and menus and everything. Maybe the player can come in and change that key. Or we actually probably would ditch it altogether and make the movement mode in the menus or add to menus. As a quick aside, very much unlike I've done here, if you're going to use a to-do, place it at the start of the comment or in a separate line. Otherwise, Visual Studio's task list won't be able to display it properly. You could use a search across the whole solution for the string to do, but that's much less convenient. So pop it at the start of the comment or on a separate line. Okay, or maybe we'll make it auto switch between keyboard and gamepad. We'll decide that later. So what we're trying to say is if we push the key, then is in direct mode needs to be toggled. Now, how would I do that? What's a single line for me saying is in direct mode? How do I toggle that Boolean value? Do you remember? It's just is in direct mode equals not is in direct mode. So we're simply toggle mode. Okay? And that's it. So that if statement just toggles the mode. I'm just going to get rid of this to do add to menu later. Okay. So this code just says every frame, see if we hit the G key. If we did, toggle the mode. Otherwise, we need to just ask a simple question. If is in direct mode, then what are we going to do? Well, we're going to process direct movement, which we don't have a method for that yet, but we'll just put a comment. Why a comment? Because it'll still compile. So process direct movement, else, what are we going to do? Well, we're going to process mouse movement in that case. Okay, and come down here, tab in. Now, there are much better ways to deal with your brackets. We'll talk about that a little bit later on. I'm not showing you Visual Studio Mastery right now. I'm not doing any wizardry with the way that you can wrap things in brackets. We'll talk about that a little bit later. So we want to play the game for a second, just check that it works exactly the same, because it should be not in direct mode and working absolutely fine. WSAD don't work, and the gamepad won't work either. By the way, with your gamepad, if you have a gamepad and you want to use it, you need to have the gamepad on or plugged in when you open Unity. If you don't, it won't recognize it, just to let you know. Unity comes built in with default bindings for the Xbox. It's actually talking here, joystick reconnected, controller Xbox One for Windows. That's what I'm using here. And just to let you know, it must be plugged in before you use it. So now we need to start thinking about how we process direct movement. How are we going to do that? Let's make the method. And let's think about declaring that method. And it's private because it's only used by this class. It's void because nothing comes back from it. And then we start implementing it. Great. So how are we going to process direct movement? Well, we actually can go and borrow code from the third-person user control. If you think about what it did, it read from the horizontal and vertical axes. Well, that's a perfectly reasonable thing to do. And the horizontal and vertical axes by Unity, as I've just said, will already be set up under project settings and input as mapping to your joysticks, as well as WSA and D keys, almost certainly. So if we look horizontal and vertical axis here, they've got mappings to WSA and D, and also they have a separate mapping to the joysticks. All right, so they're already set up for you. So you read the values. Now, it doesn't have cross-platform input manager. Why would we use cross-platform input manager when we're not a cross-platform game? Well, we're not going to make this for mobile, so we could just say input.getAxis, reducing the number of dependencies. So let's do that. Let's say we don't need cross-platform input. Right, now the next thing we need to do is take some inspiration from the third-person user control. What does it do? Well, it calculates camera relative direction. We've decided we always want camera relative, so let's just borrow that code. Why make our life hard when we don't need to? Now, there's some member variables here we don't have. mcam forward there. We have m_move. So there are some things that we may need to create ourselves, a couple of member variables in a second. Let's deal with the mcam forward first. So it looks like we just need to create a vector3 called mcam forward. And actually, all I need to do is put the word vector3, not 2, in front of mcam forward. Why m for member function? That's what they're doing there. So I can actually declare it right here in line. So we've got an mcam forward. Then it's forming this thing called an m_move. Again, we don't need to be caching this. We're not caching this anywhere else. So we might as well use it just inside this method. So again, we create ourselves a vector3. And this is just to break down these lines for the movement. Now, to get hold of the main camera, we can actually just use this static method on camera.main.forward. I wouldn't go with more than, .transform.forward. I wouldn't go with any more dots than that. That starts to look nasty, but we'll run with that for now. Camera.main.transform.forward. And that's what we put in there. So whereas in the third-person user control script, they went and store these in a variable called camera main, we can just access it straight off the camera static property called main there. And go and get the main camera, find its transform, find out what forward is, find out what right is, and just let the code that was already been written for us calculate what's been coming in on the axes and what we mean by camera forward and what we want as a move vector to pass on to our character. So then finally, all we need to do is the same as we do in process mouse movement, is just call mCharacterMove with the right parameters, which is just like that. Arguably, you could factor that out, but repeating code twice, i.e. here and here, is absolutely fine. If we happen to do it too many more times than that, we want to factor it out somewhere else. Okay, so we're just trusting the third-person user control code, and let's try and see how this works. So I click around, I'm in this type of control mode in click to move mode. Now, if I carefully click in the game window and hit G, we have no affordance, which is bad and we can sort out in a little bit. But what happens? If I click, nothing happens. If I use W, S, A, and D, what happens? Nothing. And nothing is happening on the gamepad either. So something's going wrong with the direct movement. So we just go back to our script and start breaking that down. So I'm going to let you get your hands on this now, because I've rabbited on a lot and written a lot of code, and you need to get your hands on this and understand how it works and see if you can solve this bug, and I'll come back and do it with you in just a moment. So Optionally, if you want a controller in your game, set up controller movement, ensure you can toggle modes, and share your thinking about whether you're going to be supporting controller and direct movement in your game or not. So go ahead, pause the video and do that now. Okay, welcome back. So I was midway through trying to get this to work, and we realized that processing direct movement was not working. So let's firstly make sure we even arrive in this method. So we just print a simple thing saying direct movement, like so. And we just make sure that that gets called every frame only when we're in direct movement mode. So back to Unity, get the console open, simple just tracing through to see what's wrong. Don't know what cursor to show as a one-off error, we don't mind that. If I had now hit G, we're in direct movement mode, and it's just saying direct movement, direct movement, direct movement, but it's not working. So that's okay. Why is it not working? So let's look a little bit deeper. Oops, without moving the player under the enemies. Let's go and see and just dig in and see, well, okay, we're getting this far. We're getting get axis horizontal and vertical. That should be working. Let's find out. Let's print the values of H and V, something like that, and see what we get. So G for direct movement mode, that's being logged out. And then we are getting values coming in when I hit the keys and when I move the joystick. Okay, so it's a simple step-by-step process to say, well, why is movement not working? It's not because we went from a cross-platform input manager to a plain old vanilla input, which is only going to work with everything but mobile, basically. So then what's happening? Is it likely to be finding the camera? Is it likely to be getting a decent move vector? Look, it's really simple. I have copied a line that says always move, not at all, rather than m_move. Okay, so that is just a simple typo, and that was what was going wrong with mine. But the process of you getting your hands on the code and trying to work out what went wrong hopefully helped you to understand what's going on. So let's hit G. There you go. WSA and D is working. Now clicking is not working, and then the left stick on the controller is also working. Good news. So I'm going to get rid of this minging log here about the cursor raycast layer hit. I don't think we need that anymore. I'm also going to get rid of the log that says we're in direct mode. I think that has already gone. Yes, it has. That's great. I'm going to ask myself why we get a cursor not sure what to show, and it's probably because of timing of this script. We could suggest that the cursor affordance comes late in the late update, and I think that that will get rid of that initial error when we start. Let's see. Yeah, it does. So let's do that. I'm moving the cursor affordance code into a late update rather than an update, so that in the very beginning we don't get a condition where it's ray tracing before the scene is set up and it doesn't know what layer to hit. So that gets rid of that error just by setting late update here. And generally we're in pretty good shape now, actually. There's no affordance as to how you get into gamepad mode, but hey, this is just a debug thing for now. So G does it and gets you out again. It toggles away. Make sure now that our player prefab is all right, so we can get rid of third-person user control script. We can even, if you want to, boldly go and actually delete it from scripts in the standard assets third-person character scripts. Third-person user control can just go. We don't need it. Then we want to take our player, make sure his prefab's applied so that all of what we've done is kept. Check he moves. He's got no third-person user control. Great. Final thing to do is just go to brick scene, and without changing his scene, just check that mouse movement works. Great, and also if I hit G, that I can take direct control, and I can. So I now have direct control of the character, and that is the kind of close of a chapter to some extent. We have got our very initial part of this game going. We can move a character around, and we can do it with gamepad, and we can do it with keyboard and mouse. So I would say this is a win. By the way, we're not doing nav mesh movement of our character in our game. We're not letting him pathfind around things because it just complicates quite a lot of the movement. For example, if I go back to my combat sandbox, if my camera's in tight, or even if it's just here, if I was to click up here, he would end up going backwards towards that point. And if our camera was in a lot tighter, then it gets really strange, actually, because he would run off the screen. Imagine I couldn't see this part of the ramp. I'm like here, and I click here. He would run backwards up here and round this way, which is, well rather round. I'm not precise enough with this control, but he would run up this way. And that would mean him running in the opposite direction. So then you start implementing code that says, well, look at all the waypoints of the path finding, and if it goes off screen, don't do it or something. And you end up realizing that if it's good enough for Diablo's straight line finding, it's good enough for us. Yes, we could implement some slight obstacle avoidance, but really, you just don't need it. So we're going for not controlling by AI. If you want to control your player by AI, then hang on till the next section when we will be putting a navigation mesh down in our scene, and we will be making the AI enemies use that navigation mesh to navigate themselves to us, and it will be very obvious to you then how we then get the player to use the nav mesh if we wanted to. So congratulations on getting this far, and we have movement, so see you soon.